We're going to go over a couple of homework assignments. Number 24, is that right?
Yeah.
Alright, let's put a couple triangles here. Something like that. It's not exactly like that, but it's pretty close. Make that a little bit bigger so we can work with. And then you got another one. Make that smaller. About right there. Actually, the smaller one's on the left, isn't it? Doesn't really matter. It doesn't matter, you're right. But we'll make it look kind of close to what they have. Alright, and this is W, X, and Z. And this is SR and T, SR and T. And then this is 5, and this is 6. Alright, and now an important thing that they tell you is this. They tell you the triangles and how they're similar to each other. Because the information right here, there's no way you can tell which ones are corresponding to what. Okay, so they say WZX is similar to triangle SRT. SRT. And they say the perimeter of SRT, we'll just do this, the perimeter of triangle SRT is 15. Alright, well, let's see which ones match up. Let's just write it in here. W and S, well, it looks like it's set up just like you thought it would be, right? Those are equal. Z and R are equal to each other, yeah. So these two are equal, and of course these have to be equal as well. Alright, and you want to find what?
Find the perimeter of.
You're trying to find the perimeter of the given triangle of WZX. So we're trying to find the perimeter of this one, because we already know the perimeter of this one. Okay. First thing you do is do the scale factor, right? Scale factor is 5 over 6. Remember what we said yesterday. The scale factor is equal to the ratio of the perimeters. Okay, the perimeters have the same ratio or the same scale factor as what the actual scale factor is of the sides. So if the scale factor is 5 to 6, now we're going to do the scale factor of the perimeters. So do we know the perimeter of this one?
Yeah.
Of this one? No, we don't. We'll just call it P for perimeter. Is that all right? And then what's the perimeter of this one? Okay, they tell you, right? It's 15. So now you didn't know. Now you don't even know how much this is and how much this is, do you? But you do know what the perimeter of the whole thing is, which is 15. Everybody see that? Okay, and now you can just do the cross multiplication and solve for the perimeter. Well, let's do it. Let's do the math. Watch. 15 multiplied by 15 multiplied by 15. Okay, how to do this? 3 goes into that, right? Twice, and 5 times, and what do we get? 25 over 2, and that's the perimeter. Remember I said 12.5 or 12.5? It's the same thing. 25 over 2 is 12.5. Simpler than this?
I did 6 over 5.
Yeah.
Got that answer, and then divided the perimeter of that.
Why is that simpler?
It just works better in my head.
It does?
Yeah,
This works better in my head. I have to see stuff out. I just can't. I'm not the type of person that can just do stuff in my head, so I have to see it all. I got to see formulas. I got to plug stuff into formulas. That's me. So I tell you, I would.
I just did
She went 6 over 5.
over 5 and got like 1.2, and then found the perimeter.
Yeah, but why even use a decimal? I mean, I would consider. Yeah, but it's so much easier doing it like this, I think. You don't think so? You go 5 over 6, or you can go 6 over 5 equals 15 over P, or 5 over 6 equals P over 15. You don't think that's simpler? You just, I mean, yeah, that's fine. And if you get it, and if you understand it, that's fine. But there are times, though, where these things will be getting a little bit more complicated. I would just be careful. I would just be careful trying to do too much in your head. But people do think differently. People do think differently, and I don't think. I'm very, like, if I put something together, I always have the instructions out and I follow the instructions. I'm a very, very much an instruction type of person. Maybe that's why I like math. I don't know, maybe I'm not a real man then. I don't know. Okay.
You said, well, maybe I'm not that manly.
I said a real man. So
Record that for all the
it's recorded. I don't know, but I like instructions. I like following instructions, and that's why I like to do it like this, because I know how to set it up. I set the scale factor of the sides equal to the scale factor of the perimeters, and then I just do the work and work it out. So
Why did
there
you
we go.
put a line and then you connected the rest of the line around the box?
That's how I make my boxes.
Yeah, you
I
do,
always do it
one
like that. I
line,
always go like
and
this.
then you go like that.
I don't know. Do you make your boxes like that? I don't know. What do? You just make one big box
1,
like
2,
that?
3, 4. Yeah, but you stop.
I know. I do this. I guess I could keep going like that, but I don't know.
Yeah.
Who cares? All right, let's do 26. What? I go like this, and then I go like this.
Except they're always
So I do it
rounded.
in two. I do it in two parts. I don't know why. It's just, I don't even think about it. That's what I do. All right, 26, right? No, you must be hearing things. It's Tiffany listening to the thing when we're trying to teach class. No, she interviews people on the little recorders, and she's listening to it so she can write down the quotes so she won't misquote anyone. We're doing 26, is that what you said?
Yeah.
All right, let's take a look at this. Here's the picture. Let me use a different color. There's too much yellow right there.
No,
So,
it's not. I like yellow.
let's see. DEF. Shh. Let's settle down now. DEF, that's this little one right here, right? Is similar to CBF. CBF is this one right here.
Wow, I like your lines.
Yep.
You should just do one squiggle.
This is good enough. Okay, so and then DF is 6, so let's put that in there. And then FC is 8, so that's right there. And then they tell you the perimeter of CBF, which is the bigger one, and we have to find the perimeter of DEF, which is the little one. Okay, so let's do this. Let's find a scale factor. Let's use another color. What do we know here? We know that this angle is equal to this angle, correct? And they actually tell you, we know which angles are equal, because, yeah, DF, so D and C are equal to, so I guess this one right here is equal to this one up here, right?
Yep.
Because they correspond to each other, and, of course, these two would be equal as well, right there. So that's pretty helpful. I like to do that because then it's easy to see which sides correspond to what. Now, they only tell you two sides, so obviously these probably, okay, correspond to each other, but let's just make sure they do. Look at the 6. The 6 is opposite what? The arc with 3, or the angle with 3 arcs, right? Look over here. This is the angle with 3 arcs here. 8's opposite that, so 6 and 8 do correspond to each other. Would you agree? So the scale factor must be 6 to 8, but we just make it a little easier on ourselves, and we'll just go 3 to 4. Okay? I mean, you can use 6 to 8 if you want to. You don't have to, but it's just a little easier to go 3 to 4. So watch, if I compare, I'm comparing the small one to the large one, correct? So 3 to 4 is equal to, now, do I know the perimeter of the small? No, I don't. So let's just call it P for perimeter. You can call it X. You can call it whatever you want. I like P for perimeter. Over what? The perimeter of the big one. Do I know the perimeter of the big one? Yes, 27. So really, it worked out pretty much the same. It just had a whole bunch of other stuff all around it that maybe bothered you a little bit. Okay? And then what do? You could cross multiply, but since P is on the top, what can we do? Multiply by 27, right?
I just cross multiplied.
Yeah,
So
can
much
we just
easier.
do cross
No, let's not.
multiply?
Watch. Let me show you. Come on. Look.
I don't think in fractions. That's
Okay,
my problem.
that's what I'm trying to get you to do. I'm trying to get you to think in fractions. So watch. If you cross multiply, you'd have to do this. Everybody listening? Shh.
4P.
I'd have to go 4P equals whatever 3 times 27 is. What's that? 81? Is that right? I think it is, isn't it? Yeah, I think it is. And then I have to divide by 4, and then there it is. I can keep my answer 81 over 4, okay? They wrote it as a decimal, but you can keep it 81 over 4 if you like. What is it? It's 80, right? So 4 divided, that's 20 and a quarter, right? Which is 20 and 1/4, or 24.25, whatever. But look what you had to do here. With this, all you had to do was one step. Just multiply by 27, and then there you go. 81 over 4, and you're done. You got to see that, right?
Yeah,
It was
I like those.
so. I mean, yeah, you could cross multiply. There's nothing wrong with that. But I'm just saying, in one step, you can get P by itself. Because what is that 27 doing to that P? It's dividing. How do you get rid of something that's being divided? You multiply. I'm just trying to show you little shortcuts every once in a while. I see them. Okay, if you don't like it, it's perfectly fine. You can cross multiply if you want. I'm not going to tell you you can't cross multiply here because you absolutely can. I just think you're saving a step if you just multiply by 27. We did the same thing earlier with the other problem too,
I
right?
think it's easier to do the fractions. The reason why I don't is because I make mistakes a lot when I do it. I know fractions, but like I
Well,
know
learn to work with fractions, I'm telling you, because when you get into algebra 2, and the reason that I harp on fractions a lot in here, and and to learn how to use fractions, especially my college algebra class, I harp on using fractions all the time because when you get when you get into algebra 2, you're going to be doing a lot of stuff that you just can't do in a calculator. You can't just turn into a decimal. You're going to have variables. What do they call those? What's the
Letters?
word? What's the word? Yeah, it's called. No, hold on. Give me. Shh, don't say anything. It's called. I almost have it. It's not concrete. It's the other one. It's abstract. Abstract fractions. Okay.
Can you
So
explain
you'll be doing stuff with variables and exponents and things like that you can't really do in your calculator, and you have to know the rules for fractions. You have to know to multiply by reciprocal if you're dividing a fraction. You got to know how to do that. You got to know how to find a common denominator. For instance, this is off topic, but we'll do it anyway. Watch. You might have, I'm just making this up off the top of my head. Okay, you might have something like this plus 4y cubed over 6a cubed b squared. Look, you might have to do something like this. Now, is this something you can do in a calculator?
No.
Don't think so. Okay, but what do you have to do? You got to be able to add common denominators and all that. You have to know your skills, your fraction skills, in order to do a lot of stuff in Algebra 2. Okay, so that's why I harp on making sure you know how to write it as a fraction and write it, Can you put stuff in decimals? Of course you can. And in fact, in real life situations, I was talking to Ms. Monsbach this morning about this. We were talking about rationalizing the denominator. Did you ever do that? Like if you had this right here. Remember doing this in Algebra 1? Was this something you did in Algebra 1? Multiplied top and bottom, so it's 3 squared to 2 over 2. Remember that? Okay. Now, a lot of math teachers get really hung up about you doing this kind of stuff, and math books do too, because they teach you how to do this. But Mrs. Bonsbach said, I don't know if her husband's an engineer or what he does. He does something with numbers. But he said something, listen, he said something like, who cares if I turn this into this? Because all I'm going to do with this is stick it into a calculator and get a decimal number anyway, right? I think Mrs. Bonsbach said she took like a history of math class or something in college. I never took that, but she said that like way back in the day, it didn't make sense to divide by an irrational number. So we made all the irrational numbers in the numerator, and we made sure the denominator didn't have one. So really, it's kind of like old school stuff. I talked to Mr. Jackson about it, and he said that having a square root on the bottom is really not that big of a deal. Anyway, we're getting way off topic here, but that just goes. But there are times when you need to work with fractions. So when there's times to work with fractions, I'm going to work with fractions, okay? And everybody in here should know how to do that. I told Mrs. Swam, when she went to, she's teaching 6th grade math now, I said, please, Mrs. Swam, make sure these kids know how to do fractions. She says, absolutely, because she got frustrated because kids are coming up not knowing how to work with fractions. And she said that's going to be her goal, is to make sure these kids know how to work with fractions. So hopefully I'm going to have some kids that, and you guys, yeah, and you really should. I think it's important that you do. Okay, enough of that. Enough of that.
You have like 10 minutes.
That's okay. We're gonna try to start on some stuff here. All right, we talked about similar triangles. We're gonna talk more about similar triangles right here.
Select our
I'll
homework.
tell you what. I just don't want to ruin the flow of the moment here. So let's just go to the next thing right now. Okay, we'll collect at the end of class, but right now, let's just kind of get into this a little bit. Now, earlier, if you remember, now let's listen. This is not break time. Okay, we're going seamlessly into the new lesson. Right? Yeah, it's 7-3. 7-3. Sorry, I don't have a fancy thing up there, but 7-3. All right, so what we're going to do, we got two triangles right here. I copied and pasted, hit the shift key, made it smaller. So what do you think is true about these two? They're similar to each other. All right. Before we said we had to know what in order to determine that they're similar. We had to know that all three corresponding angles were all equal to these three corresponding angles. And also that the corresponding sides were what? In proportion. Okay, so that was 6 things, wasn't it? 6 things. 3 angles, 3 sides that we had to know stuff about. But just like when we did congruent, remember back when we did congruent triangles, we said, okay, they're congruent triangles if all the corresponding angles are equal and all the corresponding sides are equal. But then, like the next day, we had a lesson that said what? Hey, guess what? We don't have to show all 6 things. What can we show? Do you remember the first thing that we did with congruent triangles? What was the first way that we could prove triangles congruent to each other without showing all 6? Side, side, side. You remember that? If I can show all 3 sides, I don't have to say anything about the angles. So that cut it in half, didn't it? Only 3 things I had to show. It's kind of the same thing with this. All right? Very, very, no pun included, but similar to what we were doing back with the congruent triangles. All right? So here's one that we've kind of talked about a little bit already. But let's take a look at this. What if I told you that this angle is equal to this angle? Is that enough to say that they're similar to each other? Nah, because this angle could be different, could be a completely different shape and everything else. But what if I did this?
Yes, because the isosceles. No, the third angle.
Third angle theorem, which mean, yeah, so third angle theorem would mean what? So if I was told that these two are equal to these two, the third angle theorem says that these right here, the third angle has to be equal, right? But I don't know anything about the sides, do I? Actually, I don't have to know anything about the sides. You can try it yourself. You can take a triangle that all 3 angles are exactly the same, and you can move it, twist it, do whatever you want to it. If they're going to be similar to each other, those angles will always be the same. All right? I could make this triangle bigger or smaller. Watch this. I could take this and make it even smaller. But what's true about this triangle and this triangle? They're still similar, aren't they? I could make this triangle a lot bigger than this one, okay? Because I hit the shift key, right? And I hit the corner, and that means they stayed in proportion. So I can make it smaller than this, bigger than this, as long as the sides are in proportion, right? It's they're similar to each other. So as long as those angles are equal, all 3 corresponding here, all 3 corresponding here, then they're similar triangles. Now, we didn't have to say all 3, though, did we? Because we could always use that third angle theorem. All we had to show was what? 2 angles of one triangle equaling what? Talk to me. 2 angles of one triangle equaling 2 angles of the other triangle. Okay, they got to be corresponding. Okay, so actually, no, all it is just if 2 angles of one triangle equals 2 angles of another triangle, then these triangles are what to each other? Similar, not congruent. They're similar to each other because they're not equal in sides. The sides are corresponding. So what do you think we call this? We have 2 angles equal 2 angles. What do you think we'll call it? We'll call it angle. Now, it's not congruent, is it? So we have to make it a little different than congruent. So we don't just say angle postulate. We say the angle similarity postulate. Similarity. I think it's a postulate.
Yeah.
Yep. So we just accept that. Okay, there's no proof for this. We just accept it. Oh, sorry. I'll make my box different. I don't want to. See, now I've got to think about it. Is that better, Caitlin? You didn't even watch.
Oh, yes. Oh, no, it's gorgeous.
It's one big
Very
box
crooked,
now.
though.
You like that? I did that special for you.
For me,
Okay. So that's called the angle similarity postulate. So if 2 angles of one triangle equal 2 angles of another triangle, then the triangles are similar to each other. So if they're similar to each other, what do you think you can say then about the corresponding sides? They have to be in proportion, don't they? Okay, because if I've established that the triangles are similar, that must mean that the sides are in proportion. Everybody got that? Okay. All right, let's move on. Just for the sake of time and effort, let's use the same exact triangles. Is that okay? I mean, if I had more time and I was a little more creative, maybe I'd use different triangles for this, but I'm not, so. What if we had this? We'll go through this kind of quick. What if I was given, let's see, I just want to go in order. Okay, remember we had side, side, side congruence? Okay, well, on this one, I'm going to put some letters in here. A, B, C, D, All right. Now, I can't really mark these because I can't mark AB equal to DE because they're obviously not equal to each other. Would you agree? All right, but I can do this. What if I was able, what if I had some numbers in here and I was able to do this? What if I took AB and I compared it to DE? And what if that was equal to, let's say, AC over DF? Okay, and then what else do you think? BC over EF. Now, I didn't say anything about the angles, right? In the first postulate that we did, we just talked about the angles, didn't talk about the sides. This one, we're talking about the sides and not the angles. Now, notice, I didn't say the sides are equal to each other, but if all three sides were what? In proportion, right? So all that stuff right there means the sides are in proportion. So if all the sides are in proportion, what do you think you might be able to say about these two triangles? They are similar to each other, okay? And that is a theorem. It can be proven. We're not going to prove it in here, but it is a theorem. All right, so if all three sides of this are correspond or in proportion to the three sides over here, then the triangles are I almost say congruent. Not congruent, what? Similar. They are not congruent. Actually, they could be congruent. To tell you the truth, I shouldn't say that. Hold on. What was I going to say? They're oh, I don't have to say anything about the angles at all, do I? I didn't have to say anything about the angles. But if I now know that they're similar to each other, what do you think I can say about angle A and angle D? They're equal. What about B and E? They would be equal. C and F, they'd be equal. Yes.
Does it matter what side you put on top of it?
No, you could have gone from the right side to the left side. You could have done it several different ways,
I mean, like, you know how you did
as long as they match up.
You know how you did AB over DE?
Yeah. Right, that's what I just said. I said you could go from this one to this one, or from this one to this one. Yep, it doesn't matter. It doesn't make any difference. I normally just go from the left one to the right one. Not necessarily from the bigger one to the smaller one. Like comparing them? It's just a ratio. Oh, yeah. Good idea. I didn't name it. What do we call this thing? What do you think? Nothing about the angles. It's all had to do with the sides. So what do you think we're going to call it? Not just side, though.
Similarity.
Right, we're going to call it side, similarity. Similarity. Nope, we do it like this.
It's gonna be like side, no, S.
Yeah, we're not going to do SSSS, though. We'll side, similarity. Okay? If you want to put the squiggle there instead, I guess that would be okay. Yeah, that'd be all right, I guess. I don't even know if they're going to ask you to write that, but if they had to, you could. So, and this is a theorem, by the way. This is not a postulate. All right? So it's side, similarity theorem. All right? Does that make sense? We don't have to know anything about the angles, but if we know all three corresponding sides, if we know all the sides are in proportion, then we know it's a similar triangles. And we got one last one to do. And we got to do it quick. And let's make this smaller right there. Okay. And let's go ABC again. Again, I'm not being very creative today. Not that I usually am, but you get the idea. That's good. I will go different color. No, I don't want to go that crazy. Watch this.
Oh, yeah.
What if... Well, no. Watch. What if I only knew that angle A was equal to angle D, but I did know this. I knew that if I compared AB to DE, that equaled AC to DF. What if I knew that? This information in blue right there. So AB to DE and AC to DF, and I knew the angle in between. The angle in between, that's important, isn't it? So what do you think I would call this thing? I'd call it side angle side and then similarity. Okay? Put dots on there. Alright, so it's called the side angle side similarity. I don't really put tick marks here. I don't want to put tick marks, do I? Because, now if you wanted to, I guess you could put like one big one here and one small one here. Maybe two big ones here, two small ones here. Just to show that they're not equal to each other, but they are what? In proportion. They're in proportion. Okay? Alrighty?
Can you do one of the examples? Like,
You know, I don't think I have enough time to do an example. You can read the example. You're big kids. You can read. I've given you enough basic information. I will take the homework in a second, but as soon as I write the lesson down for you to do today. because we got behind, and I can't be behind 2 days in a week. I could deal with 1 day. So it's section 7.3. It's page 479, 480.
9 to 24, right?
It is 9 to 24, yes. 9 to 24. There it is, right there. All right. Read the example. It'd be a good idea to read the example to see what you're supposed to be doing. I think you can get it. I mean, you knew how to do congruent triangles and all that, and it's kind of close to it.
Can you help me with number 9 real fast? Because I was looking at it.
Yeah, let me collect the homework, then I'll take a look.